What happened on the day when a single asteroid managed to wipe out an entire species of the Earth? We will tell you today. The dinosaurs, who famously occupied the planet before the apes, had a rather tragic ending to their story. So how did the asteroid manage to kill every dinosaur species? What happened the very day the asteroid killed them? And are there chances of another such asteroid crashing into the Earth? Stick around to find it all out. We have all heard stories of dinosaurs as children, seen movies where one thing goes wrong and suddenly the dinosaur infestation is back. But we all know that is not the case. In reality, almost 66 million years ago, a massive asteroid came in and swept every dinosaur off the Earth, making it one of the most significant recorded asteroid strikes ever. While most stories emphasize on the stunning violence that occurred in the moments to days following the impact, it was the long-term environmental repercussions that finally wiped out most of the dinosaurs and much of the rest of life on Earth. Imagine a normal day. The sun is shining while the waters are gushing at high speeds, and amidst this, an asteroid the size of a mountain is speeding towards Earth at around 40,000 miles per hour, while this forgotten world of dinosaurs and oversized creatures carries on with life. A fireball significantly bigger and brighter than the sun flashed through the sky for a few moments, then a moment later smacked into the Earth with an explosive yield of almost 100 trillion tons of TNT. The impact created a crater of more than 115 miles across and vaporized thousands of cubic miles of rock, penetrating Earth's crust to a depth of several miles. The event triggered a cascade of worldwide disasters that wiped out 80% of life on Earth, including most dinosaurs. The discovery of Chicxulub crater in the Gulf of Mexico in the 1990s provided scientists with a precise when and where for the event. However, the exact mechanism by which the fallout wiped out so much life on Earth has remained a mystery. The first ever core samples from the Chicxulub crater's peak ring were collected in 2016 by a team of British scientists who were studying an offshore drilling rig in the Gulf of Mexico. They said that the stunning Earth swelled massively in the seconds after the impact and created a massive circular structure within the crater walls, forming this ring. Researchers seek to obtain a better grasp of the remarkable forces unleashed that day by analyzing its topsy-turvy geology. A team of geophysicists from the Imperial College London created an impact calculator where users can enter a few pieces of essential data, such as the asteroid's size and speed, and would generate realistic images of the events. Joanna Morgan, who was one of the lead scientists on the project, said you can plug in different distances from the point of impact to see how the effects change over distance. If you were close by, say within 625 miles, you would be instantaneously or within a few seconds killed by the fireball. Indeed, if you were close enough to see it, you were dead. According to Gareth Collins, a planetary science lecturer at Imperial College who assisted in the development of the program. An observer at that distance would have been burned by the blast of heat radiation 9 seconds after the impact. Trees, grass, and shrubs would have literally exploded, resulting in instant third-degree burns to the whole body of anyone there. The flood follows the fire. Depending on the area's topography, the impact could have generated a massive wave of up to 1,000 feet or 305 meters in height. The accompanying earthquake would have been more violent than anything humans have ever recorded or experienced, according to the low-end estimate of 10.1 on the Richter scale. According to Rick Astor, professor of seismology at Colorado State University and former president of the Seismological Society of America, a seismic event of this size would be the equivalent of all the world's earthquakes going off simultaneously for the preceding 160 years. Ejecta would begin to pour down a little over 8 minutes after the impact, drowning the burning landscapes behind a blanket of molten grit and ash. The ground would be buried beneath hundreds, if not thousands, of feet of rubble closer to the impact zone. A surge of wind would rip through the region at 600 miles per hour 45 minutes later, scattering debris and demolishing anything that remained standing. The explosion's sound would come at the same time, a 105 decibel roar as loud as a plane flying low overhead. An observer further away from the blast's direct consequences would be treated to the sight of darker skies and an apocalyptic show of shooting stars caused by the impact debris falling down on the Earth. They wouldn't have looked quite like regular shooting stars or meteors, says Collins. Meteors burn up at higher speeds and get hotter. These would have been re-entering the atmosphere at lower altitudes, traveling slower and emitting infrared radiation. I'm not entirely sure what that would look like. Some sort of red glow would be my guess. The sky would darken as the red glow faded, as ash and debris swirled around the globe, creating creeping dusk. Collins says for the first few hours, there would have been close to total darkness, but soon after that, the sky would begin to lighten. The following weeks, months, perhaps even years, were probably somewhere between twilight and a very cloudy day. Now, let us talk about the end times, but before we do, we would like to thank you for successfully making it till here. You can extend your support by subscribing to the channel and liking the video. Now, let's check out the end times. While most stories emphasize on the stunning violence that occurred in the moments to days following the impact, it was the long-term environmental repercussions that finally wiped out most of the dinosaurs and much of the rest of the life on Earth. Photosynthesis would have been severely hampered due to the prevailing dimness created by the dust cloud. It would have taken months for the soot and ash to rinse out of the atmosphere, and when it did, the rain would have been acidic mud. Massive fires would have released massive amounts of chemicals, causing the planet's protective ozone layer to be momentarily destroyed. Then there was the impact's carbon footprint, which, according to geologist David Kring of the Lunar and Planetary Institute, unleashed an estimated 10 trillion tons of carbon dioxide, 100 billion tons of carbon monoxide, and another 100 billion tons of methane in one fell swoop. In effect, the asteroid's aftermath was most likely a tremendous 1-2 punch of nuclear winter and rapid global warming. That's where the fresh core samples from Chicxulub crater can help fill in the blanks in this infamous saga. Morgan explains, the drilling program will help us understand how all of this affected the post-impact climate, how much material was ejected into the stratosphere, and what that material was. So it goes without saying that the aftermaths of the asteroid were extremely catastrophic, and of course, if humans were present back in the day, they could have somehow managed to escape the dinosaurs. But there was absolutely no escaping the asteroid. With increasing global warming, destruction of natural resources, and multiple upcoming crises, humans are also set to face an apocalypse the way Earth's previous inhabitants faced. There are predictions that humanity will wipe itself out, just like the asteroid did to the dinosaurs, except we can actually stop it this time. So, what did you think of this tragedy? And are you ready to start living a more mindful life to prevent a possible doomsday? Let us know in the comments below. Thanks for watching this video. We'll see you next time. Goodbye.